Today I'll be demonstrating how simple it is to make a part on the ОМАХ machine by basically envisioning and then making a part. Now in order to make that part, the first thing you have to do is tell the ОМАХ computer what you want the part to look like. I can do that by simply bringing in any CAD drawing file from virtually any CAD program. Or if I want, I can use our own little layout program here to go ahead and create the part shape. Now let's just come up with something simple here. How about a simple rectangle with a hole in it somewhere? Say something like that. This is the geometry I want to make. I could have brought this in, as I said, from any CAD program. The first thing I have to do is specify what quality of cut I want. Now I can do anything from a very fast quality one for roughing out parts, that sort of thing, to a very precise quality 5. What I'll do today is use a quality 3, which is kind of an average part quality. I go ahead and I put in some lead-ins and lead-outs that will automatically then start me in my lower left corner, which is what I selected, come up, make the hole, and then go over and make the outline of the part. Once I've done that, I can do something called pathing, where I'll go ahead and, first it reminds me I need to save this part, so I'll go ahead and save that drawing. Then I'll tell it where I want to start, and you can see what it's done here. It tells me how it plans to move the cutting nozzle itself. It's going to cut on the inside of this hole, so I get the exact size I want, and on the outside, so I get what I want. This is also where I would find out if there was a problem with my drawing, say 2 lines that didn't connect. But I say that's fine, we can go ahead and save that. And now we'll go ahead and go to where the real action is, and that's the make part of the program. The make part of the program is where the real computing occurs, because now what I'll do is I'm going to tell the computer what material I'm going to cut this out of and how thick it is. In this case, I've got some 1/2-inch aluminum in the table right now, so I'll go ahead, note that I have aluminum here. I have a whole file of different materials, and it's easy to add your own custom materials to that file. I put in the thickness that I'm using, put in an offset that's half the diameter of the cutting jet, and I'm ready to go. And this is where it really gets interesting, because the computer goes through and it computes 2,000 times per inch exactly what velocity, acceleration, and movement it wants for the nozzle in order to control jet lag and make a precise part. It also tells me exactly how long it'll take to make the part. In this case, 0.98 minutes. And this is an exact number that I can use for time studies. Everything I've done up till now I could have done on any laptop or standard PC, because the software will fit right in there. But now I'm actually ready to make the part, so I'll go ahead and move the nozzle to my desired location. I got this muff that I've put on there to keep it quiet and clean when it's piercing the material. Raise the water level a little bit again to keep down splashing and noise. And I'm ready to start. It's going to quickly auto square my tilting nozzle here. This gives me the most accurate part using this tilt-a-jet. And now I'm ready to start. Going ahead and making first the circle in the center, and now it'll make the outside of the part. And now you can see how that controller is coming in. It's allowing it to go fairly quickly along the straightaways. Then it'll slow down automatically for the corners. Again, to give me the part quality I want. Coming into the second turn, it's doing something we call corner passing here, where it's automatically set itself to go slightly past the corner and then spring back. It just allows it to make the part faster. And it's done all this automatically with the computer model that's built into it. Now it's finished the part. I can go ahead and raise the nozzle up. Reach in and get my little part out, and there it is. Directly from just an idea in my head to a final part in literally a matter of minutes. After all these years of working in this technology, it still amazes me how quickly we can go from a concept to a final part with very little operator intervention. It was a very simple thing to program.